Well, good morning, students. Happy Wednesday to every single one of you. Hopefully you've had a good night's rest. Hopefully you had your breakfast this morning, maybe even some coffee. I've got my coffee sitting right next to me. If you hear some very loud slurps through this video, that's me. That's me sipping on my coffee. It's the perfect temperature. Love perfect temperature coffee. Good stuff. Hopefully you had your breakfast this morning. I had some Raisin Bran Crunch. And hey, I'm ready to rock and roll. So, as always, I'm going to start off with some answers from the homework. Here they are. This is your homework from 10.1. It's 10 through 28 all on page 701. Hopefully this assignment went pretty quickly. I didn't hear any complaints out of any of you. For the most part, some of you guys, it looks like you did this homework assignment in about 15 minutes, which is good. It's supposed to be an easy assignment. Today's assignment is going to be a little more challenging, but it's not going to be time consuming. I'm trying to keep the homework assignments short and sweet so you can get them done and submit them to me. So here are the answers. Check them. This is purely for your benefit. After all, at the end of this chapter, I will be throwing at you a big old quiz. So, stay on top of your studies. I want you to do well. All right, pause this if you need to keep checking answers. I'm going to move on today. I've already got my title ready at the very top. 10.2, arcs and angles. So let's get started. Go ahead and write this down. I am going to be doing a binder check at the end of this chapter, so please be writing down your notes and try these problems with me. All right, arcs and angles. Let's start off with arcs, shall we? And of course, I'm looking at it, and my very first word is central angle. Scratch that. We're going to start off with angles. I need to define something called a central angle. Now go ahead and write this down with me if you would. A central angle is, and let me read the definition for you. I'm not going to have you write the definition down in your notes. We are going to draw a picture. A central angle is an angle in a circle whose vertex is the center of a circle. Draw a picture. Draw a circle. Give it a center. Let me read the definition again. We're going to draw a central angle. It's an angle in a circle whose vertex is the center of a circle. So here's vertex, center of the circle. Draw yourself an angle. Everybody, this angle right here, that is what we call a central angle. It kind of makes sense. It's a central angle. It's coming from the center of a circle. Let's label this. Let's call this A, B, C. So central angle is going to be angle A, B, C. It goes from A to B to C, central angle. And this central angle could be, I don't know, a 51-degree angle. It could be any angle you really want. If you want it bigger, open the angle up. If you want it smaller, close it down. It looks like a Pac-Man, really. Any Pac-Man fans out there? Okay, central angle, perfect. That's really my lesson today, and I pretty much take this and I keep teaching off of this concept right here. There's a big concept. It's not a huge key concept, but it's a big concept. This is what I like to call it. It's the sum of central angles. And I really hope you guys all get this. I think you guys and gals are going to all get this. Before I give you this concept, I'm going to draw a triangle. Now this is not the triangles chapter. We are far past that, but this is just good review. Everybody, these angles of a triangle, hopefully everybody knows that this angle plus this angle plus this angle right here adds to 180 degrees. No surprise there. We've talked about that 10,000 times in this class. Right next to it, I'd like you to draw a circle. Now some of you know this. Now a full rotation of a circle is, if you said 360 degrees, you're right. That's another key concept that we just need to remember. Every circle is 360 degrees. Every triangle, the three angle measures add up to 180 degrees. All right, draw a circle. Hope your circles are getting better. Are they looking like ovals? Are they looking like eggs? Or are they looking like good circles? Let's draw a radius going to the right. start a radius kind of shooting up and to the left, so going that way. So we got a big central angle right there. Yes, that is a central angle. Kind of looks like that. It's an angle coming from the center of the circle. And let's shoot an angle going out this way. So really, we have three central angles that we're looking at. We have angle number, let's call this angle 1. And let's call this little guy right next to him angle 2. And let's call this big angle from here opening up to here, let's call that angle 3. Alright, here's the concept I want to get across to you. The sum of central angles. If you add the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, if you add these three angles in a circle, what does it equal? If you said 360 degrees, you're absolutely right. Nothing too crazy. It pretty much echoes this, concept over here. Every circle, all the angles add up to 360 degrees, a full rotation. After all, if you start right here and you open up, that's going to be an angle. If you keep that going, and if you keep this going, notice how it's a full rotation. If you add all the angles together, it makes a full rotation. 360. Okay. Okay. Example 1. I'd like you to find x. Circle time. Center. Okay, let me move this up a little bit. I'd like you to make yourself a diameter from top to bottom. Diameter, of course, goes through the center of the circle. 2 endpoints. Let's put the top endpoint R. Had to kind of cram it up there. V. Let's have an angle going over here to S. Angle down here. U. And let's have an angle going over here. So we've got a circle, a whole bunch of central angles on the inside, Q. And we'll put... no, I'm not going to label the center. I could. Alright, find the value of x. I'm going to tell you that this angle right here is 8x minus 4. I'm going to tell you that this angle is 13x minus 3. And I'm going to tell you that this angle right here is 5x plus 5. Kind of a small angle. Had to really squeeze that in, that little angle there. This one over here is 20x. That obtuse angle right there. Now before I give you this last angle, here's what you're probably thinking. Add all these angles together and it's going to equal 360 degrees. You can actually start the equation off. Before I give you this last angle, check this out. Actually, do me a favor. Don't write this down. Don't write this down. I'm trying to prove a point. Just pay attention. If you add this angle and 13x minus 3 plus 5x plus 5 plus 20x plus whatever that last angle is that Mr. Kosal is about to give us, we're going to put it right here, and then we're going to set it equal to 360, right? Right? That's what we're going to do. Okay, all right, Mr. Kosal, give us this last angle. Go ahead, give us this last angle. Yeah, I'm not going to give you this last angle, folks. This is all the information that you're going to get in this problem, and I'd like you to solve for x. Now this is what I've seen students do in the past. Students, they have 4 of the 5 central angles, and they don't have this one, so this is what they do. They say, let's just call it x. Don't do that. X is already being defined in variables for these 4 expressions. Don't just put x right here. X could be a negative number. X could be something that's already defined in this problem, so please don't just put x as an unknown value right there. Don't do this. In fact, we are not going to do this equation at all. So with the information that we're given, if I did give you this angle, sure, add up these 5 angles, set it equal to 360, you'll get your answer. But we can solve for x just with the information that we're given. Now, I wish we were in class, because this is the point where I'd look around, I'd say, anybody have an idea of how to solve this? And like 1 or 2 hands would shoot up, and I test your skill. But, I don't have a classroom of students to raise hands. So, folks, here's what I like you to do. I'd like you to just look at, let me cover up the left side of the circle. If you notice the right side, here's a semicircle, the half a circle. And folks, if you know that a full circle adds up to 360 degrees, what does a half circle add up to? Half circle adds up to half of that, 180 degrees. So that's the equation. Even though we're not given this last angle, and even though we're given this 20x, we don't have to use it. If you have a diameter going through the circle, which we do, it cuts it into two equal pieces. You got the half circle on the right, half circle on the left. These three are going to add up to 180 degrees. There's your equation. So go ahead and set this up with me. Add those three angles together. Plus 5x plus 5 equals 180. And go ahead and solve for x. And that's it. The problem's done. Okay, with the x's, go ahead and combine like terms. What is that? 26? 26x. And then combine these numbers together. -4 minus 3 plus 5. That's -7. Plus 5 is -2. Equals 180. Add 2 on both sides. 26x equals 182. And divide both sides by 26. I'm getting my calculator ready, folks. X equals, come on, give me a nice number. It goes in evenly, right? 26. Hey! Oh, it's off the screen. There we go. 7. Here, let me punch it out one more time. 182 divided by 26 is 7. All right. Not bad. Not bad, not bad. Go ahead and flip the page. Or go to the next question.